Hey, what's up guys? Today we are working on a 2006 Passat with a 2-liter turbo engine. Customer complaint is a check engine light. Power. So let's go straight to the scan tool and check out the fault codes. Okay, so we're not going to worry about the mass airflow. The engine cover's off. The mass airflow is a part of that. And so we have to take that off to get access to testing. The fault I want to focus on is this P0190 fuel pressure sensor G247 circuit malfunction, upper limit reached. So this is just a simple pressure sensor that's in the rail. It reads the high pressure in the fuel rail. And it is just a simple pressure sensor, 3 pins. One should be a 5-volt reference, the other should be a ground, and then we have a signal. First check we can do, just go back here. So just going under expert mode, read measure values. The fuel pressure value blocks are 103 and 106. So our high pressure, which is what our fault is stored, is 106. So this channel 1, so what this is saying is that there's 6 bar in our fuel rail. Let me start it up real quick. So I know that 6 bar is way too low for this. I believe the spec is 40 to 50 bar at idle. This could potentially be our low side pressure. Low side is 103. So we're reading about, this is read in millibar, so that's actually about 5 bar. We're about 5 bar now. We'll go up to still reading 6. So we know this pressure is too low. But what we have stored is a circuit fault. So we're just going to start doing some checks on the sensor, and I'll put up the criteria for this sensor. So basically this P0190 fuel rail pressure sensor circuit fault referred to fuel pressure sensor checking. We're not going to go into that. And the criteria, signal voltage greater than 4.8 volts. So our computer right now is reading 5 bar. Let's just go to the sensor and do some simple voltage checks. So looking at the wiring diagram, our G247 is the fuel rail sensor. It's a 3-pin. D174 is going to be our 5-volt reference. That is our pin 3. Pin 1, D103, is our ground. And it looks like pin 2, which is a gray and blue, is going to be our signal wire. So let's just do some simple voltage checks at the sensor. Let me get a shot. Let me show you where this sensor lives. So there is our rail pressure sensor underneath the manifold. And just going to get you a shot of the wiring. So it's a 3-pin. Try to get my back probe in there. Maybe one other testing location would be this 6-pin harness right here. So look at the wiring diagram. It does go through a 6-pin harness. It might be easier to do some checks there too. Either one works, so let me get the voltmeter hooked up and get my scope hooked up and go from there. Just going on pin 2. I believe it's a gray and blue wire. Alright, so I'm hooked up on this signal wire. The key is on right now. And we're looking at 0.9. So the criteria said that signal voltage, the criteria to set this P0190 is the computer will see a voltage of greater than 4.8 on this signal. That's not what we have here. So let me start it up and see if it changes. Or so it dropped down from 0.9 to about 0.76. So I would imagine that there's some sort of bias voltage on this, maybe from the computer, that the computer is monitoring to throw this fault. So if I unplug this, the car might stall, but we should be able to see some type of bias voltage on there. We'll try to get this unplugged. It may stall. So it's unplugged. We are now reading 0.04. So I would imagine that there should have been, or should be, some type of bias voltage on this circuit. So there's another connector. Down here, honestly, what we need to do right now is go to the computer, but the problem is the computer is buried under the cowl. It's much easier. Maybe we'll do another check at this 6-pin connector. I'm going to plug this sensor back in. There's our 0.76. Do another check at this 6-pin connector. So at the 6-pin connector, I'm going to go on pin 2. It is the same color, it's a gray and blue. There's pin 2. 5 volts on that one. We have 5 volts at the 6-pin and 0.7 of 1 volt at the sensor. And it looks like this is our bias voltage. And so real quick, I want to see if I can do a bypass test. I'm just going to take test light. I'm going to go to battery negative. And when I touch on this, my test lead, it's going to pull that voltage down. So we'll go back to our scan data. There's got to be a broken wire here. We'll go back. We measure values. So I'm going to touch on and off this signal wire at this 6-pin. No change there. So maybe the bypass test isn't going to work. One more thing we can do is that this would just be a substituted value, and once the computer does its self-check, it says, hey, there's something wrong here, and this is what I'm going to set it at. So we could try the OBD2. And I'm pretty sure the OBD2 has a fuel rail pressure sensor data pid. So we'll see what that one says. Should be able to get some type of reaction. This is under the OBD2. This is saying that there is 2,000 PSI in the rail. Don't think that there's 2,000 PSI in this rail. Gonna do the same bypass test. Test light to battery negative. I'm gonna touch on the signal wire. Here we go. So pulling that 5 volts down to 0. Now the computer thinks that there is 0 pressure in the rail. So that says from this 6-pin connector, our signal wire going to the ECM is good. And this 5 volts that we're seeing has to be a bias voltage. And what we have is a broken wire in between this 6-pin connector and the fuel rail pressure sensor. Just for the sake of circuit checks, I mean, we still could do a check our 5 volt reference, check our ground, but right now it looks like there's going to be a broken wire from this sensor to this connector. Just to be certain that we do have a 5 volt reference and a ground, I'm just going to go back to the sensor, back probe these other wires. That first one, 0.04, looks like a ground. And we will go to this other one, looks like the one we were just on, the ground looks brown and blue. This other one looks like a black and gray. And there's our 5 volt reference. So 5 volt reference is good, ground is good. Let's go back on our signal wire. 0.9. That makes sense. So after the vehicle's running, when you shut it off, the fuel starts to boil in the rail and it raises the pressure. So when it's running, we're reading 0.7 of a volt. Shut the car off. Pressure is now rising. I have the key on. And this is going to increase. So we need to find this broken wire. Computer sees that 5-volt bias, and it is throwing the fault. Remember the criteria: signal, sensor signal voltage greater than 4.8. It sees 5, so that's why it's throwing the fault. I shouldn't have let it run. This thing's so hot right now. So it's this pin 2 right here. So this is where I was back prepped at on this pin 2. Gray and blue wire, that's our signal wire. We have 5 volts here and 1 volt or 0.7 of a volt over at the sensor. So I'm going to give this the good old Keith tug that I've been hearing about. Someone said I wasn't doing it well enough. Feels pretty tight there. So it feels tight here, and there's only a little strip of harness that goes through. I try to tug at the sensor, but this engine is really hot right now. I can't even reach my hand in there. I'm gonna see if I can get a pick or something. Alright. I'm gonna give this a little tug on this pin 2. Can get around it. There's the broken wire. I didn't even pull hard. There it is. Broken wire underneath this. How am I gonna fix that? I don't want to pull this manifold off. Well, there's the broken wire. Where's the other end? Just looking for this other end of this wire. It's down in this loom right here somewhere. I'm just trying to figure out how I'm gonna fix it, or at least temporarily fix it. This is in a hard spot. There it is. Oh, there it is. The other broken piece. Right there. Get out. There it is.
I just gotta try to fix it now.
Alright guys, so this thing is not going to be easy to fix. And I think maybe, just for the sake of this video, I'll strip this back and run a new wire over to that 6-pin connector. Just plug it in and make sure this is going to fix the car, because this manifold is going to have to come off to get a butt connector in there. And so just to do it more quickly, we'll just fix it right there, run a wire over to that 6-pin connector. Strip this back. Sweet. Use this little pin tool to pop this pin out. Make sure I'm popping the right one out. These and wire these together, and then just put some tape over them temporarily. Tape over that. All right, it's plugged in. Let's get see if I can get back on there. Okay. All right, I'm back probed at the signal wire. I'm going to leave it, I'm just going to pop it out, maybe unplug it, make sure we have our bias voltage there, I guess. So sensor's unplugged, back probed on the signal wire. I'll focus you on the scope, turn the key on. Keys on. Sensor unplugged. Have a 5-volt reference, or a 5-volt bias voltage. Let's plug this sensor in. It's going to pull that bias voltage down. And now we have 2.36 volts on there. And get my leads out of the way, make sure nothing is touching anything. Turn the key on, or start the car. It's about 1.96 volts on our signal wire now. Go back to scope, or go back to our scan data, see what our rail pressure is reading. You can actually hear the high pressure pump. I don't think I heard that before. About 700 PSI changing. 700 psi. It's got to be in between 40 to 50 bar. We can go back into expert mode to see that conversion. Check our DTC memory first. Back to the DTC memory, you can see our P0190 now showing intermittent. To the main menu, we'll go to measure value block. .106, and right on the money, 50 bar. So that is a good number for this engine. 50 bar at idle. Broken signal wire going to the fuel rail sensor. Love bias voltage. Alright guys, so fixed another one. Broken signal wire at the fuel rail sensor. At the 6-pin connector, we had a 5-volt bias voltage from the computer. And at the sensor we had about 0.7 of a volt, which was, I guess, actual pressure in the rail. Simple voltage checks. This is just a simple pressure sensor, 5-volt reference, ground, and a signal wire. So, gotta love the bias voltage. How helpful was that in diagnosing this sensor? I mean, a simple unplug it test can reveal a wiring problem. And we got lucky being able to test it at that 6-pin connector and seeing that we did have a 5-volt reference there. If we didn't have that, what we have to do is pull the computer and do a voltage measurement at the computer. So, another one, no parts needed, broken signal wire at the fuel rail pressure sensor. I hope you guys enjoyed this video, and thanks for watching.